This is Hallicrafters Rehabs. Welcome back. Get used to mowers around here. So I had the satisfying opportunity to restring the main tuning dial one more time. This time by following the instructions, which had the string coming around this way, not that way. Plus I had to make adjustments in this right here for a straight path and appropriate tightness, but it's working reliably now. So right now I'm soaking these knobs in warm water and trisodium phosphate and about 30 seconds of the ultrasonic cleaner, nothing more than that, and then I can clean it with this electronic toothbrush to get into the grooves like that. Works very nicely. Plus there's a little bit of toothpaste that's still on it that it acts like bleach. So that's what I'm working on now, is the knobs. So trisodium phosphate is what they used to put in laundry detergent before environmentalists chased after Procter & Gamble and others, whoever it was that made laundry detergent. And they use it now for washing down, pressure washing houses, but nothing else. Causes algae blooms or whatever. Well, I thought that just less than 30 seconds in the ultrasonic cleaner would preserve this, but it doesn't. So I'll get out my artist paints and put the little red stripe back in. This has to be the cheapest paint of all time that they use. So I did get the dial lamps wired in. Here's a filament source right here, and the ground is, let me see if I can light that up a little bit. The ground is right in here, and then here's a source of filament voltage here, AC, and the ground is back under here. This was a pretty tight little hole, but I was able to get the two wires through it, and so that gets the dial lights in. So it's time to come and test the tubes, and I have a small inventory, so my philosophy is choose the best one of what I've got, including what came out of the set. My feeling is most of the tubes will be in great shape in the set based on everything else I've seen about the set, but I don't know. And I need to know which tubes I need to order anyway, so some I have more of than others, but we'll see how that goes. I'm not going to do that online. So while the tubes are being warmed up for testing, I cleaned this up using Crest toothpaste. That's not my, I don't have a patent on that. I got that idea from the sages of the Hallicrafters group's website, and but it does a really nice job, and is a whole lot better than headlight cleaner, as you can see. And that backside just wiped down with Kleenex. So now we'll put on the S meter. Kept the nuts on the screws. Turned out real nice, by the way. That looks real good. Okay, after my trip to look after my dad, it's time to put in the glass in the case front. So all I do for that is just take that cosmetic white with plain water on the side where there's no markings. The markings are a water decal, so you don't even use water anywhere close to the markings. I can see where somebody's cleaned it in the past and the decal started to move. So you just plain water to clean. And then on the other side, it's not clean there. It's got fingerprints on the other side. On the other side, I will be using water in areas where there's no decal. These are going to be replaced. So what I need to do is put in my actual microphone. This works okay, but not good enough. So, continuing on with the actual microphone this time. Well, that makes you nervous when you see red there. Yeah, it did get in the wrong place. Outside of the field of view, but very delicate. I guess I'm a pretty clumsy fella, not knowing where I am. It's extremely delicate. That I don't know why they can't use decent quality paint. So let me get a Q-tip to finish. Can't see what I'm doing. Just not even going near the letters because they're so delicate. All right, that's probably about as good as we're going to do. The next thing I do is I get the grommet. I'm just taking the biggest grommet I can find. Okay, so first we put in the bottom piece. We're going to have to line this up. I did put bands 1, 2, 3, and 4 on that side, the main tunings in on the other side first to make sure this is going to work. instead of take up a lot of time fumbling around on camera. This is not going to hold, but we'll get it there. Yeah. Towards the end. And you line it up. And it gets in the way because this is glass. Cut your hand right off. There we are, that's one side. That's the other side. And we're going to center it over the half moon, eyeball centering. Here's the bracket up here. And it doesn't quite fit, so you have to kind of coax it in. There we are. Coaxing away with my fingers. We'll get the hardware. Wherever that went. In the plastic bag. Goes in right there. Put in the washer. Assembly always takes longer than destruction, doesn't it? And it goes. There we are. And we're not even going to make it too tight. Came right out. Okay, that's in there tight. And we just take this, keep it away from those letters like I didn't do. You can see a little better this way. Alright. That's ready. I believe the next step is the faceplate. Oh, yeah, we'll talk about the tubes right now. Okay, the winners of the tube testing lottery. This 6SA7 was the original, came out of the set, tested very nicely. This 6SG7, which is a RF amplifier, was original. I had this one, which was a little better than the other 6SG7. This was a big win. This is an S6H6, and it's the best one I've got in all of my sets and all of my inventory. I don't have a big inventory of these right now, but it tested really nice. The 6SK7 is a Hallicrafters, but didn't come from this set, and that was the best one of those. 6SC7 also came as a Hallicrafters, but came from somewhere else. The 5Y3 was fine. It came out of this set. And this is a special 6K6. It's called a black plate and high quality. It actually has the filament leads are twisted around to reduce the hum. So we'll see how well that works with this substitute power output transformer. Okay, for the faceplate, first we'll take off these outer nuts. And this nut actually, well, we'll see. Maybe I don't have to do that, come and think of it. At any rate, we'll see. These come off too. They were just there to hold things in place. And we have to lean this over the edge so that we don't put any extra torque on these controls, because the controls themselves, unfortunately, are the means of anchoring the front faceplate. It's not far enough. There we go. Not the way I would like to do it, but anyway. The SX-99 had separate screws for faceplate, so there was no torque associated. I think, let's see, we have to remove that. Okay, yes, another problem solved by run 4 is right here. Used to be you had to take the nut out and use the nut and the control and everything else to, but there's enough clearance now for that to take place. So much better. Okay, so I'm going to get the hardware. I don't have it. Just wanted to, this is sort of just held in place for a little bit. I got to get the hardware out now to get this in. Okay, so, well, there's one more nut here that's not over here, so never fear. Small washer. See, we have everything we need over here. Almost. I'm looking for the right size washer. There it is. There we are. I think I'll probably use this one. Not sure it's the one that came off, but it will do nicely. Now this has a washer behind it too. I don't want the floor monster to get these. That's why I'm so slow at doing this. And my fingers are so stubby and clumsy they won't. Here we go. Then we have a washer here. Here. Okay. And then it's time to put in, I want to clean this off. So I'm going to take a moment or two and clean this mess off. So these things don't clean up very well. So I'm in a hurry, and you can use one of these Dremels, can't reach over here, with a wire brush, and that actually does a pretty quick job. And if you're not extremely careful, a very light touch, you can create a missile and go clean across the room, which we don't want to do that. So that's funny. Oh, these things are in very deep. And this I cleaned with in the ultrasonic cleaner. I also did this in the ultrasonic also, but still, it's not the thing that works all the time. I mean, it doesn't get everything off. So we insert this through here. These are way out. These are barely in there. I then polished this with chrome polish, and then followed it with Renaissance just to make it look nice. Alrighty, move this out of the way. We can put the knobs on. Alright, and let's start with the main tuning. I'm using regular hex screwdrivers, not the Hallicrafters. And we'll speed this up a little bit. These knobs just don't go slap on. This shaft was actually bent, and I straightened it a lot before it got on the system, but even then it was still bent. And I had to readjust the bracket back here again, but it's doing pretty smooth and it's pretty close to, about as close as you'll ever get it. And so they have to be, and they're a little bit off, you know, as you can see. There's another issue which I just noticed, and that is the balance between these two set screws. That gives it a wobble. So let me see if I can work on that. So this always comes off when you clean these knobs. The paint that I think they use the same paint contractor for this as they did for the lines on the dial. But I don't have my artist paints with me, so we just have to do as best can. This is designed for model planes and stuff. We'll go through and put these on. First, let's turn it off. Yes, now it's off. It's always easier off the edge of the table. It slipped, just like that. Okay, so we'll just keep working on that. So these little knobs I cleaned with that, first with the ultrasonic and then with the Dremel and wire brush. And I bet I don't have the right one of these. Oh. But I'm going to have to set this because it's not going in. That's just faking me. So this is the right one I use for this purpose. Now I'm going to have to set that to half gained, but I'm just putting it on right now. In fact, it doesn't matter where I put it in. That's actually not the right one. It's too close in. Rubs the surface. That's correct. We'll have to set that later. This is too far out. So we'll take these and push it in. Oh. Well, that's because the brackets are located wrong. I have to change the bracket. Let me show you real quick. That bracket needs to be flipped. It doesn't just go slap in. Exhaustion. Hours later, getting these correctly put in by turning the brackets around took a lot of time. Don't you love rework? And that's what it all was. Rework, rework, rework. Anyway, it's in place. This is not set properly yet. Stand by, receive. Okay, that's the front. We got the back to do, connecting here. I got one more knob to put in, but I'm tired for today. That about broke my back right there. Try again in the morning. Where I left this last night when in utter exhaustion was I had finished putting all of the front controls, which takes a lot of time to get the orientation right, to get these to move smoothly without rubbing. You could put felt behind it, but it's really not necessary if you align everything up properly. So everything on this side is working good. Now we have to turn around and finish off on the back side. And that's why they call this a boat anchor. Okay, so we have to wire up the S meter. And there's a positive, and it's the red lead. And remember, I had moved that terminal strip back some, so there's less lead, there's less, first goes these little insulators to keep you from coming across B plus accidentally. Then comes, that's the positive, so there's still plenty of lead there. And I like to put a washer in, even though there wasn't one. I have copper washers from other sets. It goes in here. Oh, this little thing, it's time for it. So it goes in before the wires. This is the keep your mitts away insulation for the S meter, which has B+ voltage on it. Alright, now we take this in here, we bring it around. I believe the washer holds that into place. There we go. Comes around. We'll lightly bolt this in until we get the other one in. And the washer. It's not the right washer. I actually have copper nuts from another set that I want to use. It's not the right one either. Here we go. This is it. One copper washer. Then the wire. And the copper. I've had this bad connections and the S meter doesn't work, so of course I have to lose the nut. Right now my tweezers are with the mess monster somewhere. That's the way it should be. So I'm going to put this copper nut used on earlier models in place of the aluminum one. Start up the receiver and nothing happens on the S meter. Begin here with your with this connection as your debugging. I guess that would be true with any receiver. Let me get my nut driver. Right size. And always a little bit hand tight, but with a little extra torque, but not heavy duty here. Okay, so this folds over here. First of all, that comes up, and we got a little bit of an interference because it's that short length, so I want to cut that. There we go. So it's straight up. This goes down in here. And they fold over like that. There we are. And that comes down like this and slips inside the notch. Ta-da! Okay, now we've got to move this around so it doesn't interfere with the cords. Here's the other. Will that have enough length to it? I don't know. It may not. Okay, we're going to have to splice and lengthen this. So we have to do some other testing as well. So last thing is, if you've ever had to adjust the S meter, it's always reaching over in behind. I hate that, and it's very hard to do. But when you have a big fat knob, it's easy to do. Let's back this out a little bit. Okay. And I need to find these 3 screws. Then we'll do a quick splice of this. There's no way around it. This yellow was not long enough to make it through here and then back to the source, and you don't know until we're at this point. Okay, I'll find these screws and then take it over to the soldering station, and we'll do the next step. I don't know if you know it. Let's try and get this closer. Camera was trying to. Okay, I don't know if you noticed it, but I had these wires crossed. This one was going over here and that was going there, so obviously there wasn't enough length. So, okay, so now this is going to go up on its side, and for the first of many, many hours in that respect. And I thought of another test I needed to do before. I need to test the filament circuit, which has always been a hope and a guess for me up to now. I hadn't figured it out, but now I think I have a plan for testing that before we power it up. So let me get set up here and we'll go. Well, guess what? All this time, I have a Lazy Susan. Isn't that neat? One of my favorite channels is Jim Lindeas, and he has a Lazy Susan. I'm sitting there watching it. I said, wait a minute. Okay. So to test the heater circuit or the filament circuit, I'm going to lift this lead to ground, and I should be able to thoroughly test to make sure there are no grounds on this circuit. It's always been, well, we'll use the dim bulb tester and all this kind of stuff, hoping that you don't have a short and mess things up. Well, now there you can test it. I just didn't think about it before now. So we're just going to take this solder right back out here. Let's clean this off. Yeah, came right out. Perfect. So, let's get this one, which has the beeper. See, the resistance on the filament line is like 0.2 of an ohm. And none of my instruments are, that accurate. So you have to do a continuity test. That would be step 1. Let's put the, and not in camera. So first is the ground test. there shouldn't be one. It should be open circuit. Ah, yes. There's not exactly as simple as I thought. There is a connection to ground at every heater. But it is reading 0.4, okay? Whereas if I'm doing ground, 0. Okay, so there's a solid 0.4 there. Let's see if we have continuity to all the .6. .6. We can get rid of the buzzer. Sometimes your thoughts don't quite pan out. Okay. And then one more over here. And here somewhere, I forget where. Here is the heater right here. Okay, and the heater right here. So very little resistance in there. What I should do is pull the tubes out, then there wouldn't be continuity, but I'm not going to do that. So I should have done this test sooner. Make sure my bulbs are kind of, yeah, that one. Okay, well that's as much testing as we can do with the tubes in place. But theoretically, if you pulled all the tubes, then you could do a filament test instead of hope and pray, which is what I'll have to do because I'm too lazy to pull it. I think I got it done right. With that, this radio is ready for startup testing. And that will mean a careful power up of the filaments first with the rectifier tube pulled and some measurements taken to make sure everything's normal. Assume nothing. And then there'll be a slow, deliberate powering up of the B+, checking voltages at each tube. At first just the plate and the screen, but then as we get closer to the nominal values, we'll take measurements everywhere and look for anomalies, and there will be some. It's just the reality is we're never perfect in what we do. To compensate for that, you have a robust testing program. Once the voltages are stable, the anomalies are resolved, then we can start doing looking at things like making sure the signal is making all the way through and do the IF alignment and stuff like that. Don't expect anything in terms of signal getting all the way to here because of all the ways that reconditioned those IF transformers, and all of these are in random locations. Not a problem. It just takes time and deliberate testing. So with that, I can say we'll finish this video and do and bid you thank you for watching. Be safe, and it looks like we're coming out of all of this. See you soon.